For number 6, we are given 1.3 squared is equal to v. And what we're supposed to do with this is to use the definition of logarithm to write this from an exponential equation into a log equation. And remember what that definition is log base a of x is equal to k if and only if a to the k is equal to x. So what we're given in this case is something that looks like this, and we're trying to rewrite it so that it looks like this. So the 1.3 is what's in place of the a, so that's what goes in place of the base on our logarithm. So we'll have the log of base 1.3, and then the k is the exponent. The 2 is what's in place of the exponent, so that tells us that it goes in place of the k here, so on the other side of the equal sign. And then what's left to go in place of the x that we haven't used yet is the v. So we would have the log base 1.3 of v is equal to 2. For number 8, we're doing the same thing. We're given 16 to the 2x equals 215. So what's in place of our base a is the 16. So that's what goes in place of the base on the logarithm. And then in place of the k, the exponent, that's the 2x. So that goes on the other side of the equal sign by itself. And then what's left over that we haven't used yet is the 215. So that's what goes in place of the x. So we have log base 16 of 215 is equal to 2x. Number 18, we're going the opposite direction. So now we're given a log equation. The log base 5 of 8 is equal to d, and we want to use our definition to rewrite that as an exponential equation. So now we're going from something that looks like this to something that looks like this. So the base on the logarithm, that would be the 5, so that's what's going to go in place of the a, in place of the base in our exponential equation. And then in place of the k is the number on the other side of the equal sign by itself, which in this case is the d, so that's what goes in place of the exponent in our exponential equation. And then what's left over that we haven't used yet is the 8. So 5 to the d is equal to 8. And number 23, we have the natural log of 2 is equal to x. Now remember, whenever we see that natural log, that's understood to be base e. So that e is what's in place of the base a on our logarithm. So that's what goes in place of the a in the exponential equation. And then what's in place of the k, what's on the other side of the equal sign by itself, this x. So that's what goes in the exponent. And then what's left over that we haven't used yet is the 2. So we end up with e to the x is equal to 2.